Hi, fifth years. Listen, I just want to comment that you did really well on that classwork, okay? I know a couple of you said to me I had difficulty with 7D, which is why I'm posting this video up. However, I have to congratulate you guys, that was excellent. You've taught yourself the hardest part of the question, and as with most topics, you know, sometimes I know it feels like you're going to the darkness, but same with when you're doing the past paper questions now in the next couple of weeks. You know, just keep going as hard as you can until you actually hit the block wall, and then it's just some of it's just down to experience. Particularly with this question, I think it's when you get the hang of this question, it'll be one of your favourites, right? So let's go through exercise 7D. Three out of the four, I think I got the first question right. So the important thing is here, right, and I've drawn, let me just put the camera up a little bit so I can, and is we have to now at the very, very least get down to this line, right, because that's our setup, okay? Limited information here, just speed of U, angle A, angle B. So that's all we can fill in here. I've used Q here for the second ball, right? And we can say that U sine A is equal to V sine B. Some of you did that initially, so that's fine, okay? Because the Jacob law doesn't change. Then we set a principle of conservation of momentum. That should be Newton's law of restitution. That should be an L. And Newton's law of restitution. Just plug them in, and then you know you want to see how then you can combine the two of them to get your answer, which most of you did, right? So I'm going to rush past that one. What I'm going to do as well, I'm going to take a photo of these and put them up, right? So if you're not catching it during the video, don't worry, put the photo up. Question 3 was a beauty, wasn't it? Now, so this is our scenario, same direction, 4U, 2U, same mass, okay? So that's our at the top of the screen there, that's our setup, and we end up with two equations from the principle of conservation of momentum and Newton's law of restitution, okay? Now, I've written here, when I was doing my notes for this, again I've drawn the line, that's the minimum requirement, right? And then we're on to problem solving. Let's see what we need to do. At this point, we want loss of kinetic energy is equal to, it's a show that question, mu squared bracket 1 minus e squared. I.e., so this is what I want you to be thinking now, right? We got these two bits of information. We know the kinetic energy before is half mu squared, and the point I'm trying to make here is we don't need P and Q in our answer. No P and no Q in the solution in the show that part, right? So rearrange to get P and Q in terms of E and U, because the solution is in terms of E and U, and M of course, but we know that the kinetic energy is half m v squared, right? So if I add the two of them, I get rid of the Q, okay, so that's 1, that's 2, I add them, and I get P is equal to 3U minus EU, factorising P is equal to U, 3 minus E. From 1 then, I sub P back in, and I get Q is equal to U. So now I've got P and Q in terms of E and U, which is what we want in the show that part of the question. Really important thinking problem solving skill there now, just to, you know, do the basics. What do we want? Can we rearrange to sort that out, right? So let me slide that up. For the loss of kinetic energy, we need the total kinetic energy before and the total kinetic energy afterwards. So before is fairly straightforward. Half m, so total means both of the particles, right? Half m times 4u squared, half m times 2u squared. That gives me 10 mu squared before. Total kinetic energy afterwards involves a bit more work. It's half m times P, which is U3 minus E, all squared, half mQ, which is U3 plus E all squared. Okay? So we need to work a bit on this to see if we can simplify it. This is what I do. It doesn't mean you have to do this, but this is what I recommend. work the squared bit out separately. So it's half mu, half m, oh I've done it the other way around anyway, half mp and half mq, or whichever way around they are, right? So if I multiply this out, that's 3u and 3e, multiply it twice, we end up with this and this, right? So just be careful, because this is where mistakes happen. We've seen this before already in the course, okay? When we do the hard work, and we're just going to be careful when we multiply out. So from the previous page, this is what we had, okay? I'm now saying that this is equal to that, so I'm going to sub it in. I'm saying this is equal to that, so I'm going to sub it in. I'm factorizing, bringing u squared out, u squareds in all of them. Then I'm simplifying, okay? See, the positive 6e and the negative 6e cancel out, so I'll just get 9 plus e squared inside. So back to the initial kinetic energy, which was 10 mu squared. Take away the kinetic energy afterwards, right? Bearing in mind this is what we want the whole time, mu squared 1 minus e squared. So I'm going to multiply out that bracket for now, then end up with mu squared, and when you factorize you get what you want, okay? Difficult question. I think I'm going to go back to the key here. The key here was this part, right? Because I think that's where you could get stuck. It's going back to when we get shown that question, what do we want to happen? We do not want P and Q in our solutions. Let's write P and Q in terms of what's in the solution. In this case, U and E. Okay. I'm not going to do the second part for you, but I have set it up for you here. Okay. So I would like you to try these, because the more you do, the better equipped you get to do. So this is the setup, and the workings are fairly similar to the first part. It says 4u is now coming in at 30-degree angle, right? So that's positive, that's 4u sine 30 on the vertical, which is 2u, 4u cos 30 on the horizontal, which is 2u root 3. Okay, so I'll put that in here. We know the j component doesn't change. The other ball is stationary. Okay, so that's our setup. Try and follow it the same method as we did the first part, okay, to finish that off. Okay, so from your solutions, I looked at them online, right? So this is the one that caused the most difficulty, I think, along with question 3. Oh, and 7, but I've done 7 previously, haven't I? So if you're still having trouble with any of these, just post it up and we'll go through them, or we'll do a class if necessary. Right, so here we have a stationary ball, one coming in at an angle theta and then going away at a 90-degree angle. Okay, that's the key here. So similar to the setup for the last one I just did, you have a vertical component 0.6 sine theta, horizontal component 0.6 cos theta. We break them up. Now afterwards it's going to be negative horizontally, isn't it? That's 0.2, it says, okay, in the question. So that's minus 0.2 cos, this angle is 90 minus theta. 0.2 cos 90 minus theta plus 0.2 sine 90 minus theta. Okay, that's stationary. We don't know the horizontal afterwards, but we know that's going to be 0. This is the important part in this question, right? It involves a bit of trigonometric knowledge. And in fairness, I'm not sure, I can't recall if we've done this, and I can't recall if we've done it in the maths class, right? So, yeah, a little bit of apologies there if you haven't. Because of well, actually, we did this. This is part of the junior cert cycle, so I'll take back that apology. Sorry, lads. Yeah. You touched on this in junior cycle as well. We should know cos 90 minus theta is the same as sine theta, and sine 90 minus theta is the same as cos theta. Okay, so I'm going to sub these in here. So I've rewritten the table suit. Okay, now we know the j component does not change because it hits along the I-axis, so I can equate them, and that gives me the answer to the first part when I rearrange it, right? So 0.6 sine theta is equal to 0.2 cos theta. I get tan of theta is a third. Then I go into my setup. Okay, I'm not going to finish this for you, by the way. So so from the table here, which is going off the screen, sorry. From the table here, we can do the principle of conservation of momentum, and we can get an expression for P, okay? Or we can simplify it down and leave it there if you want. Alright? I wrote that in afterwards because I realized then that I had to sub P in down here. I'll explain why in a second. Newton's law of restitution, again, apply it in. This is what we end up with. Okay? So I've got theta, theta, and P, the only unknowns here now. I want to find E, sorry, so E is the unknown, and I got P in. But I know that theta, a tan of theta is a third, okay? So if tan of theta is a third, that means I can construct this triangle. Cos of theta is adjacent of hypotenuse, 3 over root 10. Sine of theta is 1 over root 10, okay? So I can sub them in. I know that P is equal to this from my principle of conservation of momentum, and that involves theta as well, so we can sub them all in. So there, the only unknown I have is E. So if I sub in the information here, 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 I get a value of E. You should get E is equal to 2/3, okay? Right guys, so well done as I said. I know it's difficult. I'm not sure if it will help too much, but I'm more than happy to do an online class. I think it's working quite well so far, as long as you're understanding from these videos. If you're not understanding from these videos, we have to do something different. So have a review of these, okay? And really have a go at the past paper questions. I did give you the year, so it's 2019 backwards, last 4 or 5 years I think it was. And please keep asking questions online, and we can just do these videos or do a class through Zoom is the method we're using in the class in school, okay? Alright guys, see you later.